Very good morning, everybody. I am thankful to the organizers of this event for inviting me to give a presentation on communication and cyberspace aspects related to smart grid. As we all know, communication is one of the main pillars that smart grid pivots are. In today's presentation, I will discuss the background that makes communication to be an important element of smart grid. Communication needs of various smart grid applications and security concerns associated with smart grid information. Starting with background, the transformation of today's power grid to smart grid would bring system changes, and it will support sustainable development goals, can address energy security issues, and certainly have an impact on the society. If we observe closely, we will notice that from very basic energy metering to high-level energy management systems are going to go through major changes as a result of smart grid transition. And also, you will notice that these changes, or most of the changes, are going to take place at the distribution level. As depicted here, as the smart grid implementation matures, we envisage the utilities to get integrated with other energy intensive sectors, for instance, transport sector, to create a more complex setting. This big picture, which is now seen on the screen, which can be seen on the screen, was painted more than a decade back. And we are noticing that part of it are either have become reality or are in the path of becoming reality. Now, this is what sometimes in some parts of the world referred to as utility transformation from utility 1 through utility 2 to utility 3. The characteristics of utility 1 is vertical integration of everything, which we are very familiar with. Utility 2 will be unbundling different business and placing more attention to the environmental impact of energy generation. And utility 3 will be taking a holistic view by integrating all energy intensive sectors and operate them in coordination. And that's going to be a much bigger system than the power system alone today. And certainly, the optimization problems of the operation of such system is going to be fairly complex, requires a lot of information, and exchange of information, and processing of information. So we therefore expect more and more information to be used in real time for the operation of energy networks as they get transformed into the smart grid. The operation of smart grid, which typically be heavily loaded with renewable energy sources, makes power balancing more challenging. Therefore, when you have a fairly liberalized energy sector in operation, you will see market structures, something similar to what we are seeing here. And they are basically looking at different needs in providing energy or supplying energy, like, for instance, short term, medium term, and long term. So operating in such set of markets is not easy without a lot of information, and information is going to play a vital role, even if the sector is planning to operate within market environment. And we know that sustainability is an important aspect, and integration of renewable energy is supporting the sustainable development by means of reducing carbon footprint of energy generation. As you could see here, the reaching the sustainable development scenario, you have support coming from energy efficiency and the integration through the integration of renewable energy. And both require information to achieve or plan out operations to achieve the expected efficiency. So here too, you would expect information to play a vital role. Energy security is another aspect which is expected to come with smart grid transition, and we could see that a properly planned integration of renewable energy or renewable generation can address any threats associated with supply cuts. It can reduce or mitigate the dependence on external suppliers, producers, and also it can make you immune to the fluctuating prices. Allowing distributed generation, like rooftop solar, you can place citizens at the heart of energy security by means of self-consumption, which is going to come through distributed generation, and even creation of local markets where producers and consumers within the locality can exchange energy. And such scenarios are not only supporting energy security, but it's also supporting reliability, because due to the presence of distributed generation, the locality has the immunity against failures in the other part of the system. For instance, during a natural disaster, even a major power plants get tripped, or line get tripped. The locality should be able to sustain the supply with much higher probability than it is now, because of the presence of distributed generation. However, such operation requires a lot of coordination among system components, elements within the locality. So you need strong information exchange mechanisms. So this is where you will find even information is going to be vital. There will be impact on society if you take a look at. Of course, with the introduction of, or rather transition to the smart grid, would create the consumers to be producers in most occasions, and they have to, once they become producers, they basically become market players, and they therefore requires information, and they have to interact with cyber systems, interfaces, human machine, and take part in energy markets. And while consumers have to get involved in such activities, they will have concerns such as the infringing into their privacy through the usage patterns of them, and also whether their communications can be assured as secure, because the transactions, their communications involve finances, so that security is a concern. And also, every consumer or prosumer will not be equally literate about these IT systems. So could all prosumers can get the benefits equally? That would be kind of concerns. Well, on the flip side of the coin, some societies like Japan are contemplating to use this transition to basically take their society to the next level, they call them as Society 5.0. And so you will, if you're interested in, there are quite a lot of information about this, about Society 5.0. Let's now try to get some idea about the distinct needs of information by stakeholders of smart grid. And stakeholders need, well, we know that stakeholders need timely information if they are going to get involved in smart grid operations in the sense like markets. especially consumers. One thing that I need to mention here is that the communication needs of different stakeholders in a smart grid environment depend on the setting, because there is no universally agreed or followed structure. Different countries have different structures. Though there are similarities, there are differences. So stakeholders' needs could vary according to the country's setting. Now, if I assume a significantly deregulated environment for the explanation of information need, in such environment, you will be seeing players like consumers who are producing, retailers who will be basically interacting with consumers, then distribution network operators, transmission network operators, those who will be providing ancillary services. You will be having new set of players like aggregators and energy service companies. And then you have regulators. So this is kind of interactions that different parties would have. As an example, in Australia, but different countries will have different settings. There are challenges associated with collecting data and sharing data. For collecting data and executing commands, we rely on end devices, and their reliability is highly important when we actually deploy them for critical operations. Since the system that we are talking about, that's the power system for energy network, geographically diverse, bringing data to central locations requires connectivity, and they're going to come through multiple nodes, and quality of service is going to be an issue. By quality of service, we mean the throughput, volume of data coming in a unit time, and delay, and the reliability. How much, when you transmit 100 messages, how many messages do you get properly? And some information requires almost close to real time. For instance, SCADA and control data. And other data will be able to tolerate certain level of delay. When it comes to market-related data, you can actually support them through data exchange platforms, which are not recommended for real-time data exchanges. When sharing data, especially when somebody collects data and when you're sharing it with somebody else, the data producer's privacy is a critical issue. Now, this is what we have been talking a little while ago. The consumer's load profile tells what his life on that particular day, or if this is a common pattern, so his life pattern. And also the security. So these are kind of concerns that are related to communications and cyberspace activities associated with smart grid. Data requirements by different actors in smart grid environment is this is how you would see is like this. Well, this is typical, but different as I said, in different settings, it could be different. And this tells or shows you the quality of service that is required for different applications. For instance, advanced monitoring and control, which involves SCADA plus wide area measurement systems like VAMs. And you can see that the data frequency is much higher in such systems. And you will be needing quite fast networks with lower delays. You can see that latency, which can be tolerated, could be as low as 15 milliseconds. And demand side management can support, of course, by services which are not as good as what is required for monitoring and control and protection. Of course, as you expect, the protection requires the highest level of quality, and you can see that the reliability levels also change with the application. In general, when you deal with information, privacy, integrity, message authentication, and non-repudiation are the security requirements. And privacy is understood, and integrity means that a message sent should arrive as in the same way as it has been sent, and nobody should in between modify it. Authentication basically to ensure that the sender's identity, so that the sender, nobody can pretend to be somebody else. And non-repudiation is that once you transmit a message or once you have a transaction, you just cannot say that I didn't do that transaction. So that's basically. And utilities are pretty vulnerable to cyber attacks. And of course, the most recent attack was pipeline attack in the US. And in fact, attacks on utilities are much more than we think. And a recent survey has found that close to 50% of the utilities that was taken into account during the survey has undergone some kind of attack over a period of a year. And when it comes to security requirements, it's quite important to understand that the security requirements for the internet users and the smart grid is not the same. The smart grid requires much stringent security requirements. For instance, in the internet, I mean, in most applications, the authentication is not or access control is not very significant or rather present. But for the smart grid, it needs to be should be there in flows throughout the system. And attack detection in the internet we implement on some critical nodes, but here you have to make sure that every device being protected more or less. And the security implementations should be as the lowest possible level upward in the case of smart grid, whereas in the internet you can actually have it being implemented at higher levels. So it's basically the point is that it's different and you need to assess them carefully. So just to summarize what we discussed, Smart grid is a network consisting of large collection of active elements which are autonomous. They can operate on their own, and therefore to assess the state of the system, I mean, you need a lot of information coming from those devices, and so a lot of information exchange is required. And of course, information exchange associates a lot of requirements. Certain information require protection against breaching the privacy of process. And different applications require different quality of services. It depends on the application. And the security implementation of smart grid is not same as the security requirements of the internet. Therefore, careful selection of communication technologies and security requirements are vital for reliable and secure operation of smart grid. With that, I conclude my presentation. Thank you very much for your attention.